All right, let's now get started. The only thing I will mention is, if you haven't really done the survey on the programming test time, please do so. I'm going to send a final reminder today. I think so far 2 p.m. on a Saturday seems to be the best time for everybody. Okay, and then I'll confirm that as soon as I can. But as I said, please try to make some arrangement for that. And I promise there's only one test that you have to take on Saturday. Hopefully not the exam, but exam is kind of up to the registrar office. I'll confirm this as soon as I can. After that, we'll just go with the schedule. I want to start with, I think one of you guys, I forgot which one, you kind of asked me about object-based language, right? I forgot which one, but oh, you did. Okay, awesome. I did some very quick search. It seems like, I guess today, if you see any languages supporting object feature, it's very unlikely they will only be object-based, meaning that they don't support any inheritance or polymorphism. I think for historical reason, they only mention one example here that's purely object-based called Visual Basic, even before .NET. So I guess maybe other languages that you would have heard, like a C#, Java, and Python, I think they will be object-oriented. Okay. However, if you want to define your own domain-specific language, let's say you want to define a language on your own, you don't want to make it too complicated. In that case, you might just make it object-based without supporting inheritance. That might be possible. Okay. But I think for your knowledge, you should really know what object-based really mean over here rather than object-oriented. Okay. So today the plan, I would like to first finish off the introduction of this course, just about giving you another idea about what a compiler can look like. I think this one here, I'm just going to give you a little bit details over there, not too much. I don't want to spend too much time on that. And then once we're done with this compiler second example, and then we'll move on to the more compiler-related stuff, okay, the more technical stuff. Okay, let's go one by one. And we want to do one more experiment on attendance checking, just one more. And then starting from next week, we'll take it more seriously. Okay. All right, so that's the slide we just went over last time. So what we want to do now, let's say, we want to do a compiler to go from input being not exactly a language you have seen before, but something just define on your own, the features. I'll show you what it looks like, but it's like a Java-like language. And we want to compile that into SQL database. But the important question is, why do we want to do such compilation? Okay. Oh, sorry. So why do we want to do this? What's really the value? What's the practical value for that? And these are the two things you want to think about that might be applicable to your project as well. You want to think about the input should be as high level as possible for the user to write some programs in it. The backend will generate something that nobody will care how it looks like. So that's why we want to choose something that will be better for data management. So now the question will be, do you want to choose to write your specification in Java or in SQL? I think usually people might just aim for maybe Java because it's much easier to think in terms of objects rather than tables. So I'm not going to assume too much knowledge about database because I know it's not a prerequisite for this course, but I just want to mention database will be quite an important subject as well. That's something you may want to look into yourself. That's a table just to summarize the justification for this compiler. What we want to do is, at the front end, we want to specify the data and also updates. When I say data, I mean attributes. When I say updates, I meant methods, like mutators. And then, once we get to the back end, we want to persist all the data we have, which themselves are very valuable. We want to persist them in the relational databases. That means, whatever attributes you might specify, they should be turned into tables at the database. Whatever methods you specify, you have to somehow turn them into nested SQL queries. So that will be the challenge for you to write a compiler. I'll show you some example there. You can get a feel about how complicated it could be. All right, okay, that's the challenge. But if you're interested really into this kind of areas called object-relational impedance mismatch, simply means these two semantic domains, they are very different. To really breach from one to the other is a valid challenge. Alrighty. Okay, so this will be a new stuff for today. So let's talk about the input. The input is going to be Java-like. Okay, let's take a look. So there are two parts for the input: data, updates, these two. What about the data? So we got something called classes. I'm pretty sure you know what a class is. And associations. back year 2030, in the second year, the advanced OOP course, you learn about something called aggregation, right? So that's basically what association is. You want to build some link between two objects at the runtime. The way to specify that is by building association at a class level, right? That's something you learned before, so that's not new. And this will be some example model here. I'll show you part of it, but if you're interested, you can definitely dive deeper. So what you can take from this particular example is to imagine yourself, if you were to write the compiler for this, how would you do it? Especially after you learn about Antelope 4 after the reading week, you can definitely take this as a side project if you wish, right? That's something you can definitely take further. I can show you very briefly about this data model over here, right? Just several classes. How many do I have? I forgot. 1, 2, 3, 4, 5, 6, 7, 8. We got 8 classes over here. I'll just show you maybe a few, maybe a couple. For example, let's say over here, okay? Let's say we got a classical hotel. We got a classical room. And between these two classes, we have a single bidirectional association. And the way to read it goes like this. Every hotel has 0 or more rooms. Make sense? Every room has exactly one hotel as its host. That's how you read it, okay? Let's just do one more so you'll get an idea. What about this one over here? This one here, we got one class called the account, the other one called the traveler. So we are saying that every traveler has either no account or one account, 0 or 1. Could be a little bit simplified, but that's the way it is. And every account that exists must have exactly one traveler as their owner. And that's the owner, that's the attributes. So you can expect to see some declaration of the attributes in the example, right, according to this model. I wouldn't show you the whole declaration, that'll be too much, maybe just a few. Okay? The big picture is this would be something not even as the input of your compiler. This is just something maybe if you want to write an input language to the compiler, this will be something to consider first before you write in the input language. Okay? Any questions so far about this? Just to know what we are doing here. Okay, let me go back here and let's see. And that's about the data model, the attribute part, like associations. And I'm pretty sure for those of you who took the database course, you learned about what ER diagram is, right? Entity relationship model. That's something like that, I would say, something similar. And the behavior model would be just how you can specify the updates, like mutators. Just to make the example fun, rather than specifying like a normal Java sequence, like a variable assignments or if statements, we got something that looks like predicates. Okay, just you'll see example. Okay, I just want to show you quickly. So this slide here got many details over here, but the big picture is you ought, if we want to build a compiler, we ought to define the transformation rule to go from maybe the initial abstract syntax tree into some intermediate representation. So these are the rules. But I'm not going to read off the slides. You can definitely look into it. But I'm going to just use one small example. I'm going to use 2 to show to you. The first one will be a little bit symbolic, but hopefully you'll just get the idea. So this one here is just to say how you can turn from the object attributes into SQL table. Right? We want to translate from object into SQL. And so these are the rules over here. But let me just go over the example. Let's say we got 2 classes. We got class A and we got class B, right? So the principle is for every class, you have to create a so-called class table, right? Think about your compiler somehow is going to compile these 2 classes into some AST, abstract syntax tree. And then it is going to somehow generate the tables automatically, accordingly. Let's see. So after, oh, that's too thick, sorry. Let's say after the transformation, let's do first thing. We have one table over here called the class table, right? Just A. Let me call it A, class table. We got another class table for B, so that's simply just B over here. What columns should we put? First of all, we have to, in the object-based world, we know the notion about this, which is the object ID or the object identifier for the current objects. So we definitely need that. So there will be some ID for you to identify the object. So that'll be the first one. So you can think about every class should have, every table that corresponds to a class should have an object ID. Okay? And then this one here is simply a string value. That one there, single valued. So we can also put it. So I'll put S over here. And then, and that's it. Okay? And this attribute over here, yeah, I couldn't really choose a better name, but anyway, that's the way it is. Let's say it's going to be a collection of B's, and then it's a set of B. Okay? I don't want to bother you too much, but just understand in the following way. This is the syntax your compiler will have to deal with. Okay? Let me make it a bit more visual for you. We basically got two classes over here. We got A, and also we got B. Right? This one here, this part over here seems to be quite normal, like Java. This part over here seems to be weird. What do you mean B.A? This one here really try to specify the association, bidirectional one. Let me show it to you. So here we're saying that B's over here simply got a set of B, basically, right? So here from A actually got a set of B's over here, and the name is simply called BS over here, B's. Symmetrically, if you try to look at this particular attribute over here, it says for every B, it's going to have just a single A over here, and the name is called A. All right? So this will be 1 over here. Because this is a set, so it will be just star. If you don't really follow exactly, that's okay. But I just want to let you know this syntax has certain meaning that you should really understand if you want to write a compiler. Okay, so that's a bidirectional association. And the rule, the transformation rule is, for every by association, you ought to have a separate table. Okay, just a separate one. So the way, let me just name that in this way: A, B's, and also B and A. This is an association table over here. And every association should have some ID as well. Okay, just for that part. And then every association, let's say for this particular one, you actually got A and also you got B's, right? So I'm going to put A here and also B's over here. So that's a sketch about how the transformation can be done. So the big picture is, after getting these two classes, you're going to actually have these many tables. Oh, there's another one. I have missed this particular attribute over here. That one there, it's a multi-value. So we're just going to get another table separately. So that one's there. It's just going to be IS over here. Another table over here. So we got the ID and also just IS over here. Right? This is a certain rule you got to follow. Okay. Any questions so far? That's about how we can turn the class attributes into tables. We'll see one more example. That might be a little bit more. This might be a little bit too abstract, too symbolic, but that's just to show you some idea. If no, let me move on. That's the rule. And of course, when you do your projects, this is some initial sketch you should really have to see how I can turn the input into the output, some initial sketch. Of course, these rules ought to be need to be translated into Java to code the methods for transformation. Okay, so I got one more for you. Let's say we focus more on account and also traveler, only these two classes. And then we got some methods over here as well. We'll take a look at that. Okay, let me just show to you very quickly over here. Okay. So we got, let's say here we got account class, we got traveler class, we got a hotel class, right? The attributes follow similar logic as I explained. Let's take a look at the method. The method part is interesting, okay? Not the normal kind of method you would expect from Java. So this one here, since I say it's predicate, think about this is like an ASCII character for imprecation, okay? And then this part here, if you got a question mark, that means it is an input. Okay? And then extent is simply more mathematical term, so don't bother with that. So I'm saying that I should have one input called T. T should be of type traveler. Traveler, well, T is a traveler, basically. I got another, and also T here, it should not be a member of the register. So the idea would be if you want to register a traveler into the hotel, the traveler should not have been in the hotel already. That's why this symbol here really corresponds to over here, not a member of. I'm pretty sure you know that from 1090, right? So you can think about this part here is more like the precondition for you to really execute the register. In order for me to register a traveler, number one, it better be a traveler. Number two, that traveler should not have been registered already in the hotel. That's what it is saying. And then we're going to, and this part here is like a disjunction. Or actually, you know what? Think about it as more like a conjunction. That'd be easier. Okay? And then we are saying that once the input is actually checked to be valid, we're going to add the input traveler into the list of registered travelers in the hotel. And then, symmetrically, we want to make sure this, which is the hotel, must be registered into that particular traveler's hotel as well. Right? It's kind of bidirectional. That's about some very quick walkthrough about what a syntax can look like. Of course, for you to really define some rule for this transformation to go from Java methods or predicates into SQL queries, you need some very sophisticated rules. Of course, I wouldn't talk about it here. Yes, question?
Is this just like an example of what like our own language?
Yes, it's a good question. What I'm showing here is just one example. In order for you to really build a compiler, you need to know what the grammar is for this particular language, right? For example, you might define correspondingly, you might say a method is a rule. It could be, it must be, for example, some identifier followed by the left brackets. You know what? Let me do a little bit better. Capitalized word in the grammar usually means it's a rule. And if you got all capital, it's like a terminal, meaning that it must be spelled exactly like that. I think it might have similar convention back in 2001. But when we review the context-free grammar later, I'll mention those conventions again. Okay, it's gonna be ID followed by, let's say, left curly brackets, and then followed by, let's say, this part here can just be an expression, let's say, like a Boolean expression, followed by some expression, followed by, for example, this particular imprecation over here, and then finally, this will be maybe just another part of expression. And of course, if you want to go further, you have to elaborate what expression can be, and the grammar will just will simply go on as you need. Yeah. Make sense? Yeah.
So it's kind of like the thing that you showed yesterday when we were going over the while loop, right?
Yes, similar. Yes. Not yesterday, Tuesday. But that's okay. Doesn't matter. All right. Guys, any question about this? I think for this example here, I wouldn't expect you to know the precise detail about what the method or what the transformation rule, why it is the way it is. However, it's more important to understand the flow I'm trying to show to you. Meaning that later on, if you want to build a similar compiler, those are the steps you must make sure you understand how to proceed. Let me go back. Right. How do you specify the scanner and parser accordingly? Let's do this little exercise very quickly. Okay. What I just mentioned over here is about the parser, basically, right? Because you got to define the CFG. So this will be the context-free grammar for your parser, right? So this basically answers the second part. What about scanner? If I actually want to define the scanner for this particular language, what should I worry about? What kind of categories do I have for the scanner? Remember, a scanner is going to read character by character and somehow decide whether the character sequence is a token that's valid, right? Can you just give me some examples of tokens that should be somehow specified as part of the scanner? Delimiters, I agree. That will be the first category. So let's say for scanner, the number one will be delimiters. And for example, this will be left, let's say curly bracket. This will be right curly bracket, right? Another category, anyone? Will be another category of tokens that we might define over here. Keywords, yeah. Absolutely, yes. Thank you. Yeah, keywords. For example, you can see, well, of course, I make them already bold, pretty much like an eclipse. So you can see very obviously class, attributes, int, string, set, and etc. for sure. So there are different levels of concern. One is only focusing on how the token should be spelled. The other one is how the tokens should be put together in a context-free way. Later on, you're going to do some semantic analysis to do context-sensitive analysis, as we said. All right, good. Awesome. And this will be kind of what the output would look like. So I want to show you just one more example of transformation, and then I'll show you the most challenging part of this particular compiler. One of the most challenging part. This one here, basically just another example of doing transformation. Okay. So here, as part of the hotel management system model, we got account, we got traveler, and also we got hotel. I think this little example is nice. If you're really interested in digging further, deeper into this compiler, you can see we got account here, we got account table. We got traveler here, we got traveler table. We got hotel here, we also got hotel table, right? And then you can see we got one bidirectional association between account and the traveler. That's exactly over here. That one, there you can see we got an ID for the association. We got an owner, which would be the account. Also, we got the account, which will be the account here, and owner will be the traveler, right? That's the association table. Similarly, this particular association will also be turned into this one over here, right? You can see here we got only one account with ID 1 with balance 100. We got traveler, we got two traveler with ID traveler 2, traveler 3. We got only one hotel, 4, and the name is Glad Hotel, let's say. And then let's say this one here. Here we are saying that with this particular association, we're associating owner 3, which can be lookup here, which is Mark. And then associated with account number 1, which is over here. What does that mean? That means Mark has an account with balance 100. That's how you interpret the database table. You can see the way we interpret the data at a database level is quite different from how we did it in the object-oriented or object-based world. That's why it is a mismatch over there in the semantic domain. And to fill the gap is your compiler's job. Right? You can do a similar interpretation over here, right? And you can see this table schema is what has to be generated by your back end. Remember we said the back end? Back end should really go from the last IR, intermediate representation, to the output language. So this will be the output language. And I think this one here, if I remember correctly, that one is about MySQL, which is one of the standard. Okay. I think there's MySQL, SQLite, or PostgreSQL, but this one specifically MySQL, just for your information. And then the predicates that we talked about earlier, this one here, right? That one should be turned into so-called store procedure. Did you guys, for those of you who took a database course, did you hear about this term before? Store procedure. No? Never used them. Okay. Yeah, thinking this way. So I guess maybe in your database course, you simply write individual queries to see how to get results from the table, I guess. So store procedure is more like a function that can be defined on the server side. And then you can simply store a list of queries and group them in the desired sequence, and then to execute it all at one go. It's like a list of queries, basically, store procedure. Okay? So we're basically compiling the method from the input into store procedure in the output. Okay? I'm not going to show you the exact translation. I just want to point out to you one very challenging transformation. Let's say, well, let's recall what we have to write usually in the OO. Right? If I have a method, right? Let's say, and somewhere I must say something like this, dot A, dot B, dot C, right? That's basically something we have to write. That's called a dot notation, which is very unique to object-based language. This is to say, starting from the current class, which got attribute A, the type of A, which is a class, has attribute B. The type of B is another class which supports attribute C, and it goes on and on and on. right? That's Java. Now, the problem is, how do you translate this into SQL? You see what the challenging is, right? That would be something we have to solve. But don't worry, I'm not going to test you on the test. I just want you to know that's a challenge you have to solve when you implement a compiler. I'll just give you one example. Okay? Let's now talk about this particular path. Okay? Let's say we are now in the context of the account class, let's say. In the context of this particular class, we actually want to say this dot owner, which will bring us to the traveler. And then the registration list, the list of registered hotel, basically. And then we go to a list of hotel. That's what we want to do in the OO world, in the input. What would the corresponding output look like? I want you guys to think about here. So these are the tables I just explained, right? Remember? Take a look at this. Don't worry about this just yet. Okay? Take a look at this. How would this correspond to the table lookups? Think about it visually, and then I'll go over that with you. I think that'll be the last thing I want to discuss for this compiler. Because we ought to understand at the instance level, like example, before we can generalize it. I'll give you guys 1 minute. Okay, again, I want you to think about how, given this input path in the OO world, how can we translate it into the corresponding operations in these tables? I'll give you a little bit hints. You need basically multiple lookups in the table. But how? I'll give you guys 1 minute. Think about it. By the way, it's a challenging problem, right? So that's why I just want to give you guys an idea about how challenging it could be. Okay, just one more moment before we talk about it. Alrighty. Anybody want to try? Using this table over here. Well, apparently we have to start with this, right? This, we assume we are now in the context of account. We definitely should really go to the account table, for sure. And for simplicity, we only got one object over here. Let's say this happened to be just one, let's say. This is simply just one. Of course, you cannot really do that, in Java. You cannot write something equals an address. But let's say we can do that. Okay. This will be the starting point. How would you decipher this part over here? This dot owner. Yes.
Go to the account owner, traveler account table.
Aha, good.
And be like, oh, well, 1 has owner 3.
Exactly.
Great, let's go find owner 3.
Awesome. Thank you. Basically, let me just elaborate a little bit more. Once you see this dot owner, owner is over here, so that's a part of the by association, bidirectional association. So you go to the corresponding association table over here, and then you see that exactly. So 1 is corresponding to this. And the owner here is 3. So that means up to here, we will be able to figure out this is really referring to object ID 3. Right? Conceptually, we are really doing the same thing. But in the OO, you don't really tend to think that way. But it's really what's happening in the database table. Let's do one more. Okay? How do we continue? Anybody want to help us? Yes, over here. Of course, you can go here because rec list over here is part of this second association over here. True? And then, once we go to the table, well, we got multiple rows. What should we do? You can join maybe, but you can do something similar, right? You can do some just matching. Yeah, given that we know OID is 3 for the owner, right? So we can simply look for the owner, which would be over here. And you'll find 3. So the corresponding hotel should be 4. So ultimately, we'll get that OID is equal to 4. Right? That's kind of a simple example, right? Your compiler's challenge will be, number one, the path in the input can be arbitrary. Number two, the path that's given by the user may not necessarily be type correct. They might simply specify some dot notation that doesn't make any sense. Your compiler should do some type checking and figure that out and report back to the user. That's basically what Eclipse does. So you might need to do something like that for your project. Given some kind of path or some sort, you want to do some type checking first before you can turn that into the target. All right? All right, guys, I hope kind of enjoyed this example here. I mean, it's a very useful application. If you're interested in doing this like a side project to do the object-relational transformation yourself, feel free. I think it's kind of a nice challenge to have. Alrighty, that'll be it. Yeah, that's exactly what I just mentioned. The dot notation, definitely one of the most challenging part. All right, beyond this lecture, you can just look at the references if you want to. All right. All right, so now we're done with the introduction somehow to the course. We spent quite a good amount of time talking about the various terminology and etc. But I think it's worth the time before we dive deeper into individual components of the compiler. We'll do one by one as we lay out. Before I move on, are there any questions or terminology you want me to clarify further in this particular lecture before I move on? Anyone? Everybody is okay? Okay, good. Let us remind ourselves very quickly. I think internet should be working. So if you go to the lecture site, and then if you go to the semester calendar over here, let's look at that very quickly. You can see we are now here, September 15th. So next Monday, I'm going to release your assignment number 1. That one there is going to be related to NFA, DFA, but in a fun way. You're going to program that in Java. Maybe something you haven't done before, so which will be fun to do. Okay? I think that we'll start covering about that scanner part from today, but I don't think we'll really reach the diagram about DFA, NFA, but that's okay since you learned about them before in 2001. So you can definitely start with assignment 1 on Monday. That's okay. And the week after, on 27th of September, you will have your quiz number 1. About 1 week before, I'll try to give you guys some tips about what you should really look more into preparing for the quiz. But it's going to be in class on Tuesday, which means not here, 4th floor. Okay, just remember. All right, that's going to look ahead. And then we're going to have assignment number 2 and etc. Okay, just always remember to look at the calendar. Okay. Alrighty. Why don't we, I want to quickly take attendance for one final experiment, and then I would want to give you guys 2 minutes break, and then we'll move on to the new lecture. Why don't we do that? Okay? If you can just get your iClicker ready, and then for me, I need to refresh my location. Give me a moment. Okay, let me take a look. I should go to settings and then attendance. Yeah, currently it's still thinking, oh, maybe, I'm not sure if that's right, but anyway, I think I should refresh. It's always good to refresh that. Require and then allowed. Awesome. Okay, so now it should be up to date. Good. Let me start 4302. Okay, and then I got that challenging question like last time for you over here. Poll. There we go. Okay, if you can. I have a quick question. Do you guys see any other option to say simply take attendance rather than just answering the poll? It was back there?
Yeah. When you start the class,
yeah.
there.
Oh, over here? You mean more? You know, let me try this very quickly. Maybe you guys know better. So you mean, okay, let's say that's when I first started the class. You mean somewhere I can just say take attendance? You know what? I think to make it easy, I might just.
When we start the class, we have to join.
Yes.
Once we join,
No, they'll give you the option to take attendance.
automatic.
Automatic. Do you mind just take a screenshot? Can you do me a favor? Is it possible for you to take that screenshot, like taking the attendance, and send it to me?
Attendance percentage.
When you join
Uh-huh.
the session,
Yeah.
that counts as your attendance.
Already.
Yeah.
Okay, I think it may not be what we want because I think, okay, let's make it this way. I think I will just prepare some question anyway, like a poll, like a quiz. Of course, it wouldn't count for anyway, so you can just answer anyway.
But also to join the actual
Mhm.
class,
Yeah, you also,
be in the proper location.
okay.
You do have like
Yeah, since we are already there, so I would say we can answer one question anyway. Yeah, okay, sounds good. Okay, now I got it. That's fine. Yeah, don't worry about the screenshot, that's fine. All right, guys, thank you. I think now we are good. I assume everybody actually got their iClicker working, right? You got a question? Yeah.
Yeah, my iClicker doesn't think anything.
Yeah, same here.
Same here? Wouldn't allow you to join? But
And on Tuesday as well.
on Tuesdays as well? How about others? Others are okay, right?
on my laptop the same situation.
The same situation. I think if that ever occur, what you can try, since it's a small class, I think there might be a way for you to refresh your location. So
My phone's reliable.
Yeah.
you use Wi-Fi or the data?
I'm using the Area Plus on my laptop.
Okay. Maybe try to see next time. Maybe this setting there might be. For example, what I did was I went to my setting for the instructor and then kind of refresh my location somehow. There might be a way for you to refresh as well. If that happened again, in some cases I can just maybe take your name and then that can be taken as attendance as well. Just let me know. Okay. All right. Good. Awesome. So guys, I would suggest it's now about 3:08 according to my clock. Don't go away. Let's take a 3 minutes break. Okay, and then we'll come back. Yes. You say that you cannot join? I guess similar problem. Somehow you had to refresh your location. Yeah, okay. All right, let's come back in 3 minutes and then we'll talk about stuff. Yeah,
So
please.
it did eventually load.
Oh.
Now, should there be options that I can select here? Because if I click on this one, it looks like.
Oh, because it's already done, I guess.
Okay, so yeah, it took a while, but it did eventually show up.
Interesting.
On Tuesday, it didn't at all.
So maybe next time, let me leave that thing a little bit longer.
Yeah, maybe
So
a couple more
possibly
minutes, yeah.
a couple more minutes. No problem. I can do that. Good, good.
Should I note my name down?
Oh, don't worry.
Send you-
Today it's still
Okay.
experiment. Yeah. Yep.
You keep saying that
Yeah.
2001 was a prereq for this course,
Uh-huh.
but on the thing, it's only 2011 and 3301, which 3301 isn't offered and 2030 is.
2001. I think it's part of the general requirements because if you already completed your general second year requirement, you would have completed 2001, I believe.
Understandable, but that's only for CS students.
Only.
I'm in engineering.
Okay. So in that case, it's not really a complete disaster, don't worry. So what's going to happen is I'm going to review all the necessary concepts in the slides, in the lecture anyway. So in your case, try to see if you can digest them. I try to make them very self-contained. And then if any question, let me know. I think for the purpose of quizzes or maybe your final exam, if you study my slides, it should be enough. Of course, any other additional resource that you want to study for that, that's okay too.
Okay. Thank you.
Yeah. Okay. But good to know. But I think, well, of course, you're more than welcome to join. But just usually we thought you would be the CS students. We thought. Yeah.
I think this is it was taken as an elective course
Okay.
for your fourth year, so you could kind of do whatever you want.
Yeah. Sure. Of
So,
course.
Yeah.
I'm glad you're interested for sure.
I actually worked on compilers at my co-op, so that's why I figured it'd be
Oh.
worth it.
So did you work on Antler 4?
Not Antelope 4. I was at QNX.
Okay.
I don't know what they use for their parser, but I think it was like a custom one.
Interesting.
Yeah.
At some point, drop by my office hour. We can take a look what you did before.
I don't have any.
Oh, you don't have anything. Okay.
Yeah, because
Maybe.
I have it's company proprietary.
Oh,
stuff,
I'm sure.
So,
I'm
yeah.
sure. All right, that's okay. Yeah, we'll start very soon.
It says I'm not at the classroom. I don't know why. My phone and my laptop have the same problem. I don't know why.
I think maybe try next.
Maybe,
I'm really not sure. Maybe there is a way in your account setting to somehow to say you want to somehow refresh your location. Try to look into it to see if that's possible.
okay.
Yeah. Yeah. In the worst case, we'll take your thing manually. In the worst case, but hopefully not. Right. Good. All right. We'll start momentarily. Okay. Good. Yep. Okay. So the first topic for this course will be about scanner, doing lexical analysis. I would say this part here is going to be mainly the review of the important stuff you learned from EECS 2001. And of course, in some cases, if you haven't taken EECS 2001, I think the slides are pretty self-explained. Self-contained. Of course, if you got any trouble understanding that, just reach out to me. I think as far as the quizzes and also final exams are concerned, I think studying the slides would be sufficient. It kind of highlights all the results you should really know. Okay? But I think even if you study EECS 2001 before, you might be able to get some good insight again. Did you guys, when you learn about 2001, did you guys learn about how to minimize the number of states in a DFA? Did you guys learn about it? If you remember. Seems like no, right? Okay, that's something new you will learn. We'll learn about how, given a DFA, how you can optimize it by minimizing its number of states. That's something new you will learn. I wouldn't think usually 2001 they will cover that. Usually they wouldn't have time to do it. All right, so now the first slides, just to recall very briefly this important diagram over here, right? Let me just show to you very quickly. We'll go over some bullet points and then we'll get to the roadmap for this lecture. And I'll make the slides available after class today because there are some little exercises I want to test you right away in the class. That's the diagram we had before, and we are now talking about just the first components in the infrastructure, which is the lexical analysis. And then, so here we got input being the source program. It will be somehow treated as a sequence of character, and eventually we'll get, sequence of character. That's how you perceive the input. And after the scanner has been run, we're going to generate a sequence of tokens. Of course, another possible outcome, which is kind of implicit here, is what if the scanner decides there are some misspelled character sequence? In that case, we are not going to do any syntactical analysis anymore. We're going to stop there and then report the error. Okay? So there's something that's kind of implicit over here. May also report error if there is any invalid character sequence. Just remember, that's also one of the possible outcomes. Simply, it's misspelled. All right? And we will hopefully only spend about 1 to 2, or maybe about hopefully 1.5 weeks maximum here. And then this part over here will be big. We got to learn about some important algorithm about how to do parsing. And you will have some programming assignment as well to actually practice. And then at the same time you're doing the project, we'll try to also talk about semantic analysis. And also I want to cover 2 design patterns as well at the same time. Sorry. Not too sure why it was switched to 2030. There we go, like that. Okay, yeah, one thing at a time. Just remember we are now in the first stage of the compiler. Right, it's going to treat the program as a sequence of characters in the first stage, and then the word to really use will be recognizing. I think that's also the word you heard back in 2001. We say that a DFA, or like a finite state machine, can recognize some character string, right? So recognize will be the word. Recognize token lexical analysis, and then once you terminate the scanner, What will be the outcome? It could, of course, it should be part of the outcome that it would simply report what's not being recognized as tokens, what's being misspelled, and also produce a sequence token if nothing is misspelled. And this is the only part of the compiler that's going to look at character by character. After that, parser is going to look at token by token. All right, that's a very quick recall. And, oh, another very important word. When we talk about the scanner over here, it can only recognize so-called regular language. I'm pretty sure you have heard this term before, either regular language or context-free language. So for the scanner can only be expressive enough to recognize regular language. And we're gonna, when we review the theoretical foundation for regular language, you will see some more examples. Okay? This will be the roadmap for this particular lecture. Let me just give you a little bit look ahead. Okay, over here. Think about what's gonna happen here. If you are the user, okay, I keep saying this Antler 4. Right? Antler 4 is actually so-called parser generator tool, which is something you will have to learn during the reading week. Okay? And the parser generator, actually I should say parser/scanner generator, but usually they only say parser, which includes the functionality of the scanner. In order to use the Antler 4, you need to specify all the patterns of the tokens. For each valid token, what should be their pattern? And the way you specify the easiest way, the most user-friendly way to that would be by using regular expression. Alternatively, of course, you can simply draw NFA, and that you can be used to generate scanner. In theory, yes, but in practice, we know we don't do that. We only specify in the textual form. Once we're going to cover a little bit of regular expression today, we'll finish that next week, and then we're going to move on to how you can turn from regular expression into NFA, and then how you can go from NFA into DFA. And then once you get this DFA, it's not necessarily optimized. So you have to optimize it using some algorithm called DFA minimization. After you got this optimized DFA, you can apply another algorithm to get the code for your scanner. So we ought to learn all these stages manually. So we should know how to do that on the paper. However, beyond this course or beyond the lecture, you never do that manually. You ought to use tool to help you. But before that, you should know how to do that manually. All right? Guys, a very quick test on you. But I'm going to review that precisely. Do you guys remember what the differences are between these two? DFA and NFA. Just to start with, do you even remember what they stand for? DFA first. Automata. Very good. Awesome. What about NFA? Non-deterministic finite automata. Very good. At least we know what they stand for. And you're safe. I'm not going to call you again. Okay. And do you know what the differences are between NFA and DFA? Robbie.
NFA knows where to go, and DFA doesn't.
Not necessarily, Robbie. I think both of them should really specify how you recognize the token, so they should really suggest how you should go. Now, not quite, but on the right track. Yes. Anybody want to give it a try?
The NFA has multiple paths and the only has one.
The NFA has, yeah, that's true. That's true. You're basically talking about like this. I agree. For example, you might say here, let's say I'm now in state S1, arbitrary state. By taking A, I might go for this path over here, which might be another some complicated stuff here. Or by taking A, I can also go to another different path. Maybe that's what you meant, more path over here. That's one, I agree. There's another critical difference, which has to do with alphabet. Of course, if you forgot what about alphabet is, my hints wouldn't help. But I'm going to review what alphabet is in a moment. But does anybody know what the second difference is? Give you a little bit of hints. Let's say we are talking about a DFA. Oh, sorry, let's say we'll talk about an NFA of binary string. Let's say, for example, you take 0, you take 0 over here, right? Rather than A and B, just make it easy. So the alphabet contains only 0 and 1. But what would be the difference between NFA and DFA? What would be allowed for you to do in NFA, but not in DFA, with respect to the alphabet?
Guessing that it is.
Guessing is okay, no problem.
You don't have to include a branch for every possibility.
That's exactly the point. Yes, very good. In NFA, you don't have to specify at least a path for every character in the alphabet. But in the DFA, you must. For example, in the DFA, in this case, let's say you got state n over here. In order to go to state n plus 1, you must get maybe 0 here, for example, and then 1 here. To go another way. You must specify exactly 1 for 0 and exactly 1 for 1. For NFA, there's no such constraint. You can specify multiple, 0 or more. Right, so I'm just sketching that very quickly, but that's something we should know formally. That's something I will talk about later. All right, so that will be the roadmap. Do you guys have any concern at this point? So that'll be how we're going to proceed with the lecture. For today, we might just be able to touch a little bit about regular expression, but before that, we need to clarify some terminology. Okay, I'm going to write it down here. I'm going to go one by one. What an alphabet is. What a string is, what a language is, and also what a problem is. So these are the 4 things you should know pretty well, hopefully, by the end of the lecture. If you forgot about them, that's okay. We're going to review. So these are the 4 things we're going to clarify. All right, so let's now go back here. Alphabets. It's simply a finite, non-empty set of symbols. Obviously, empty set cannot be an alphabet, obviously, right? And we just use sigma. I'm pretty sure you used the same notion back in 2001. And also, sometimes you might also put a subscript under sigma just to say, okay, what this alphabet is for. And I'll give you an example in just a moment. You might be asked during the quiz or the exam to specify maybe a particular alphabet. And there are usually 2 ways for you to do it. If you're lucky, you know exactly the list of values that should be in the alphabet, you can numerate them. So it's what's called set numeration. On the other hand, sometimes you might find it easier to do the set comprehension, meaning that you want to specify some predicate in the notation to specify the range of values that can be in the set. We'll see example. Right? So these are the things you learn from 1090. So let's take a look. This one here is a little bit like close to numeration, right? So I'm saying all the English alphabet, lowercase and uppercase, right? A to Z, A to Z, right? I don't think you can really do set comprehension over here, to be honest, because I don't think you can do any predicate to specify that. So this way, but I wouldn't ask you in the quiz, don't worry, right? This one too much to write, okay? So you get an idea. And this will be, I would say sigma, sometimes you can assume if we don't have any subscript, just sigma. Usually you simply refer to the binary. But if you want to make it more obvious, more explicit, you can say bin, binary. Okay? And up to now, we are talking about set numeration. You explicitly list all the values in the set, in the alphabet. And this will be one example of using set comprehension, right? And using this one example, I want to just tell you, just in case you forgot from before, this will be the syntax for set comprehension, right? So we talk about set comprehension. It's going to be a syntax like this. Okay, sorry. Brackets over here for the set. There's going to be a vertical bar over here. And then here will be some expression. And this one over here is going to be some predicates. Or you can think of Boolean expression if you tend to think more programming. Okay, predicates. And of course, when I say predicates, you can definitely use any of the logical operators: conjunction, disjunction, negation, implication, right? Even more, you can use the logical quantifiers. What are those? Do you remember? How many logical quantifiers do we have? 2? Okay. Do you remember how to write them? This one? Upside down. Okay, good. I'm just testing you. Good. The other one, this? Reverse. Good. You guys are good. Good. Sorry for wasting your time. But I'm pretty sure you know how to spell it. But make sure you write the right thing, right? If you write the other way in the quiz, I'm sorry. It's too bad. I'm pretty sure you know which ones for all, which ones exist, right? Good. Awesome. If you got any trouble understanding basic, don't be shy. Come to me. I'll help you with that. Good. So that'll be just a general syntax, but we're going to see many examples today. Quite many. But we'll definitely see even more later. Alrighty. Okay, so this one here, if you try to look at that, this one is saying, if you say here, the alphabets of the decimal digits will be set comprehension, we basically want to get all the digits such that D is in between 0 and 9. It's really conforming to the syntax because this part here is the predicate. This one here is the simplest expression you can have. So we might see some example later. This one does not necessarily have to be a single identifier. It could be identifier times identifier or something, some expression. Okay, that's why I put expression over here. Right? Hopefully everybody is okay with that. We'll see more complicated one. I'll give you one exercise as well in class today. Decimal alphabet. Here, this one is meant to be the list of alphabet you can type from your keyboard. But for this one, I'm cheating a little bit. I just say the informal description. So just say sigma key denotes the keyboard alphabets. Right? So we just cannot specify it formally, but that's okay. Right? I would say I will only ask you in the quiz or the exam if there's something you can specify formally. Otherwise, I'll just tell you, for example, this one simply denotes the keyboard alphabet. Right? So you'll be clear to you. Okay, that's about alphabet. Very easy idea. But just remember, we're going to build on top on the alphabet. Alphabet is simply a set of characters. Okay. Right? Let's talk about strings, the next level, which will build on top the alphabet. A string or a word. I think the more formal term is to talk about string. But word is okay too. I think both are interchangeable. It's a finite sequence of symbols chosen from alphabet. And here, when I say finite, it can be empty, meaning that the string itself can be empty string. Do you guys remember how to write empty string formally? You guys do this. I'm pretty sure you know. Okay? How do you read that, by the way? What's the name for that? Not null. It's not called null. Starting with E. Not empty string. No. Not that. Why would I ask you if that's just called empty string? Epsilon. For your information, that's okay. That's why we're doing the review. This way, right? Epsilon. So this will be for empty string. Just remember. Because you will see that symbol somewhere in the slides. Okay, that's empty string. And then, okay, let's go. Okay. Yeah, this is apparently a word from, we'll say it's a string over certain alphabets. And apparently, every character in this particular string is a member of that alphabet set, right? That one's easy. And 0, 1, 0, 1, well, that's obvious as well, right? I will ask you later, if I say a particular string is a string over a certain alphabet, how can we specify that formally? That's something I will try to sketch together with you. But we'll do that a little bit later. For now, we don't need to. That will confuse you more. And why is this one here not a string over the binary alphabet? Why is this not? What's wrong? The dot. Yeah, exactly. Yeah, of course, this could be a quiz question. I would say, justify whether or not this statement is true. I would say this string here is a string over the binary alphabet. That should be wrong, because this particular character over here is not a member of that alphabet, right? Easy question. And obviously, 57 is a string from the decimal alphabet. That was obvious. Okay. Now, a very quick check. Oh, you got a question, right? I'm pretty sure.
That's the question. The last thing you mentioned, it says 57 is a string of the binary alphabet.
Thank you. I'm going to change that. Decimal alphabet for sure. Thank you. Cool. Yeah. How about this one here? Why would it not be correct to say 01010 is a member of the binary alphabet? Is it? Well, you don't think that's incorrect. You think that's correct.
Oh, I was going to say it's incorrect.
It's incorrect. Why?
Because binary alphabet refers to individual numbers 0 and 1, whereas this is a collection of the sequence together as a word.
That's correct. Yeah, that's true. That's true. Basically, well, even thinking this way, this is only a set with two members, 0 and 1. Oh, actually, it's more like a category error. You're saying the following. You're comparing string versus individual character in the alphabet. It's not really the compatible comparison, right? Actually, this is actually quite, even though it's an easy answer, but it's important to know why it is not correct. Let me write it down here. Okay, so let me write it down here. So 01010 is a member of sigma, let's say binary. And we know that it is simply the set of 0 and 1. Okay? But it's actually even more than that. So this is actually a string. And this is actually an alphabet. Right? It's simply just saying the wrong thing. Because individual member in the alphabet is not even the string. It's just a single character. Okay? And let me see if there's anything else. Okay, I think that's good for now. Okay. All right, let's go forward. Yeah, to really get the length of the string, just put absolute value. Just remember the convention. And then just count. And epsilon, what you guys already know pretty well, the symbol, right? Of course, it will be length 0. Concatenation, I'm pretty sure you know how to do it. I'm not going to waste your time. However, this will be something important to see why. Why would we say empty string is the identity for concatenation? Do you guys know why? Why would we say that? You may have heard about that term before, I guess. It's similar to saying 0 is the identity of addition, and 1 is the identity for multiplication. Okay? Can anybody just quickly explain? Why would we say empty string is the identity for concatenation? Not really about modify.
You get the same value back. Like,
You want to say it again? Just give a complete sentence.
if you apply an identity to some operation with another value, the result is that same.
What do you mean to apply identity?
So for concatenation, you concatenate, addition, you add.
Yeah, so I think what you want to say instead would be applying a concatenation of some string with the empty string. You just get that string back.
I want the generalized.
That's already general. So you're saying that if you got concatenation here, so empty string concatenate with another arbitrary string, either on the left or on the right, just give you original string. Yeah. Guys, quick check. What's the identity of conjunction? Well, maybe I write it down, right? Just for your knowledge, right? While you're thinking about it, maybe your mind is already spinning. Oh, what is that? Okay, that's okay. Identity. So we talk about, just for your knowledge, okay? I'm just going to summarize what we said here. We know for plus, it's 0. For multiplication, it's 1. For concatenation, it's the empty string, right? What about conjunction?
True.
Why?
Because anything that's true is still whatever.
Yeah. P and true is equivalent to P. Absolutely. Very good. And of course, symmetrically, we will know for disjunction, it would be false. P or false is equivalent to P. Good. All right. Okay, let's now move further. Okay, something more to say about strings. Okay, so here. Things start to build up a little bit more. Let's say we are given an alphabet. Let me just take a look at the time. Okay. Let's say we're given some alphabet sigma. We can say sigma to the power of k. K is simply a natural number. Oh, by the way, in this course, whenever I say natural number, I mean the number sequence from 0, 1, 2, 3, all the way to infinity. I know in some contexts, natural number wouldn't include 0. Okay? I'll write it down explicitly, right? So there will be no confusion. Whenever I say natural number, it will be simply 0, 1, all the way to infinity. Something like that. Okay, so when I say sigma to the power of k, it's going to be a set of strings of that particular length. Let's see some example, and then we have some little exercises for you to do. Oh, let me just show you the, well, can anyone actually try to define what sigma, what I just showed to you is the informal description in English. Can we formulate it using set comprehension? I want to give everybody a chance to think about it, right? I want to say sigma to the power of k, meaning that I want to find from this particular alphabet all the strings with length k. Okay, I got 2 volunteers already, but let's see if anyone else would like to try. It's okay to be wrong, by the way. What I'll do is I'm going to open up a new page over here. Why don't we start with you, since you didn't take 2001 before. Yes, go ahead.
Absolute
Absolute value of k, okay. Absolute value of k.
Oh, wait.
I'll just write whatever you say.
Oh, yeah. Absolute value k.
Absolute value of k? Is that what you meant?
Yeah. And then you have the such that.
Okay. Okay. I'll just whatever you say, okay? Such that?
When you have a 0 less than or equal to
K?
W,
Okay.
and less than or equal to the absolute value of k. Oh, wait, no, sorry. It should be absolute value of W. That's one. Absolute value of W.
Okay, I'll give you one more chance of revision. How would you like to revise it?
So from left to right, you're going to have to
No problem.
W.
Absolute value of W. I think you're getting somewhere. Okay.
Such that, and then 0 less than equal to the absolute value of W is going to go all the way to k.
Meaning less than or equal to k.
Yeah, equal to k. And there's a conjunction after this.
Conjunction?
I don't know what to put there, so I'm going to leave that as my final answer.
Something like that. No problem. Okay. First of all, I think I like the answer, even though not exactly right, but let's learn from that. Okay. If I ever criticize your answer, please don't take it personal. Like you can correct me too. All right. Okay. The way I see this, I will first of all look at this number, this expression over here. This expression here, what is the type of this expression? Is it a single string, or is it some number? It's a number, right? It's a number, right? The type of this expression here is going to determine the member type of the set. That means you are specifying basically just a set of integers. You're not specifying a set of strings. Okay, that's the first thing I want to criticize. So you guys want to be careful as well. You might write something like that in the quiz, right? Just be careful. So this is actually not right, because the resulting set is a set of numbers. That's not what you meant to say. Okay? That's one thing. Okay, and of course, I'm not too sure about question mark either, but we can, okay. Anybody want to help to evolve this answer a bit? Yeah, let me write a separate one. Sigma. Sigma concatenated with that's okay. Take your time. You might be overthinking. Might be. First of all, we can already discuss a bit. If you talk about this one here, right? What will be its type? Is it a single string, or is it a set of strings? Just this one alone. No, answer my question first, please. Set of string. But can you really concatenate a alphabet with a set of string?
I can say concatenate with X. X is a member of sigma.
How would you like to write it? Sigma still? X?
Such that X is a member of sigma k-1.
I see what you're doing. I see exactly what you're doing. Not exactly right, but you're getting definitely somewhere. I tell you what, the only where I'm not exactly happy about is when we say concatenation. We talk about string concatenated with another string. What you're doing here is you're concatenating an alphabet set with another string. That's not right, conceptually. Okay, first of all, right? But I will rewrite your answer following your thought, which I like. All right. Because concatenation only applies to two strings. And apparently, X would be a string, maybe, but sigma is definitely not a string. Let me just fix your answer a little bit. I would say sigma k will be the concatenation of two strings, X and Y. Maybe X is possibly sigma 1 and Y sigma k minus 1. I think that's what you meant to say.
But then how would you define sigma 1?
Sigma 1 is all the strings with length 1.
And how would you write it formally then? Because I was thinking for my case, right? Sigma kind of X.
Yeah, of course. I think, of course, there could be another issue with the answer because somehow, in order to define sigma k, we're kind of using the definition for sigma 1 and sigma k minus 1, right?
So for me, what I was going to also ask is sigma 0 is equal to epsilon, or equal to second king only epsilon.
Yeah, that might go a little bit too much. We're just getting overcomplicated. Yeah, but my intention here is to say you're trying to concatenate something with length 1 with something with length k minus 1. But as you correctly pointed out, if you're defining this, you're using its own definition, which may not be so good. Okay, so I would just say it's only for conceptual thing over here. Okay, but what will be the correct answer? Why don't we try? I would say the correct answer may be along the line of this, a little bit more. Oh, okay. Then write it down, and then we should take a look. Sigma k. It's incredibly easy, guys. Set of string W such that W length equal to K. That's it. Yeah, equal to K. Well, we say K should be exactly K, right? Okay, any objection? That's okay. But I really love what we're doing here because you'd rather be wrong now rather than doing this the first time in the quiz, right? Good. Yes, question?
I guess my only criticism of this definition is that W could be a character in
Oh,
the alphabet.
You know what? Actually, I think maybe that's something I.
We're also missing some formal
Yeah. I think in the no. Absolutely. W. I'm pretty sure in the slide the standard answer has that part, but I just forgot to mention. Absolutely. W is a valid string. Actually, okay. You know what? I think that's the exercise part. Very good. Okay, so this part over here, which is something I would like to talk about as well. So W, let me say for now. So W is a string over sigma. Okay, I know this is not formal. I agree. That is why in the slides, how do we make it more formal? Do you guys know how to make it more formal? Just this part. How do I formally specify, given a string, is really a string over a particular alphabet, meaning that it does not contain any character that's not in that target alphabet? How do we specify that? You guys think for just 1 minute. I'll sketch something for you. That's really interesting because you would think that's really simple idea, right? But why can we not specify that using math? It's possible. Oh, sorry, let me just go back to the slides. And then I'm just going to put that particular part there. That's why it's really good to do some formal exercise together. Okay. Let me just get this part here. Hopefully the Wi-Fi is working. So I will be able to it may not be working. Sorry, just give me 1 moment. And then I'll sketch the idea together with you. Oh, how about this will be the last bit? All right, I'll just this last bit. We're definitely running out of time. Okay, sorry, never mind. Let me write it down here. Okay. We want to say W is a string over sigma. Okay, sigma is any given alphabet. That should be equivalent to some formal description over here, right? Let me help you a little bit. First of all, let's do this one here. Let's say W is of the shape character 0, character 1, character 2, all the way to maybe character k minus 1. And then, so this actually also indicates the length of W is k. So we don't need to say its length is k anymore. So it's kind of implicit, right? I think it's a very explicit hint to you. And can anybody tell me, I just need one more conjunction? Before that, let me see, anybody can, do you understand what I'm trying to do here? I'm basically saying W is of this particular shape, which we do that always, in the mathematics, right? It has character 0, character 1, all the way to character k minus 1. We're saying that it's a length k string. But now we want to say something about maybe individual character. What can we say about individual character? Yeah. So in that case, oh, by the way, so let me say a string of length. We'll finish this, and then we should really let you go. And let's use which logical quantification should we do? For all or they exist? Upside down A, for all, right? Okay, for all, right? Let's say for all I, 0 less than equal to I less than or equal to k minus 1. I'm using I as a dummy variable quantified over 0, 1, 2 all the way to k minus 1, right? If I is the case, that implies Ci is a member of the sigma. That's how you make it more formal. Alternatively, if you really want, you might see this kind of notation as well in other mathematical textbook. This will be the generalized N notation. You can say I is a member of No, actually, you can simply say 0 less than equal to I, less than equal to, or you can say strictly less than K, that's fine too. And then you say Ci sigma. Either one is okay, all right? This one is okay. This one is fine too, all right? That's about that English part to make it more formal. You guys can think about why it will be the case, okay? That's the kind of stuff we will need later also when we get to the later review we will need. Any questions? Are we okay? Question first and then we'll, yeah. This is not exactly concatenation. I'm just saying that W is of this particular shape, this structure, character by. It's not really concatenation. Yeah. Guys, thank you. I'll see you on Tuesday. Take care.